In this video, we're going to review the differences between the mass flow rate and the volumetric flow rate. The volumetric flow rate is abbreviated by a capital Q, and it measures the volume of fluid passing through a cross-sectional area per unit time. The formula for this is Q is equal to A times V, where A is your cross-sectional area, and V is your average fluid velocity across that cross-section. Now, in terms of dimensions, Q has dimensions of L cubed per time. Area, of course, has dimensions of length squared, L squared, and velocity has dimensions of length per time. So you can see that when we multiply length squared times length per time, we end up with length cubed per time. So that gives us a volume of fluid per unit time going through a cross-sectional area. Now, the second flow rate that we need to consider is the mass flow rate. And this is abbreviated as m dot. And m dot measures the mass of fluid passing through a cross-sectional area per unit time. And here, the equation for m dot is simply rho, which is the density of the fluid, times A times V. And I'll make a note here that rho is, of course, the fluid density. Now, in terms of dimensions, the mass flow rate has dimensions of mass per unit time, m over t. And that's because we have the density, which is mass per length cubed, multiplied by the area. Cross-sectional area is length squared, times average velocity, which is length per time. And so you can see that the length cubed cancels out from the numerator and denominator, and we're left with mass per unit time. Now, it's very important to be able to move back and forth between these two different types of flow rates, and we can relate them quite easily. So we can relate Q and m dot by the following equation. So m dot, you can see, is simply equal to rho times Q, or we can rearrange that as Q is equal to m dot divided by rho. So we'll do a quick example here to illustrate these two flow rates. So for example, we have water which flows in a round pipe with a diameter of 0.1 meter with an average speed of 0.2 meters per second. And we need to find both the volumetric flow rate Q and the mass flow rate m dot. So Q, we said, is equal to the area times the velocity. So the area, the cross-sectional area of the circle is pi over 4 d squared times the velocity. So here, pi over 4, we have this multiplied by our diameter, 0.1 meter, which is squared, and then we multiply that by 0.2 meters per second, our average velocity, which gives us 0.0016 meters cubed per second. From the volumetric flow rate that we just found, we can then find the mass flow rate by multiplying by the density of the fluid. So the density of water is 1,000 kilograms per meter cubed. We're multiplying that by 0.0016 meters cubed per second. And so we end up with a value of 1.6 kilograms per second as our mass flow rate.